Evet arkadaşlar, the next topic that we will be focusing on in terms of the system properties is time invariance. Okay, we will be focusing on time invariance, or if a system is time invariant or not. Okay, if you remember, we were obtaining an input and then we were obtaining an output y of t if there is a kind of t0 shift in the input, there should be the same amount of shift at the output. That's what time invariance is called. Okay, let us work on one sample, one example here. For example, the system is given like this: 2 plus sine t times x of t. Okay, so this is my input, and for the output to be calculated, I have to multiply the input by 2 plus sine t. Okay, how do I determine if this is a time invariant system or not? So we will apply x t minus t0, and the output will be like 2 plus sine t, okay, times x of t minus t0, right? So if my input is this, I will put this instead of this term, x of t term, and then we will obtain 2 plus sine t x t minus t0. Now, if I apply this right now, if I write instead of t here, t minus t0, what is the output? T 2 plus sine t minus t0 times x of t minus t0. Okay, so now I need to check if these two, if this one and this one are equal to each other. Okay, I will check if these two are equal to each other. You can see that there is no shifting over here, and then we would say this is a time varying system. Okay, or not time invariant. Okay, this is what we would do for time invariancy. Let us have another example here, and then I will finish the time invariance part here. Y of t is equal to x of 2t. What does x of 2t equals y of t? That means I have to squeeze my data, and then this squeezed data will be my new output. Okay, my system takes the input, and then the output would be like x2t. It's a kind of squeezing system. Okay, so is this a time invariant system or not? Okay, this is the question. How should I approach to this problem? First, I should say x of t minus t0. If this is the input, okay, then I should write x2t 2t minus 2t0. Okay, so what happens here? Instead of this t, I put this t minus t0, and then 2 times t minus t0 will be equal to 2 times t minus 2 times t0. Okay, how about if I apply this and then see if y of t minus t0, and then I will see if this one now, if I shift my signal by t seconds, okay, then it would be 2t minus t0, which is not equal to this, right? So I should check these two if these two are equal to each other, and because they are not equal to each other, this system is not time invariant. Okay, not time invariant. I hope this thing is clear. If you think about how we approach to this problem, if a system is time invariant or not, we have shifted the input by t0 seconds, and then see how my input is changing, and I apply. You see here, instead of t here, I will put, instead of t here and t here, I put t minus t0. And if these two are equal to each other, then I would say time invariant. But if not, then it's not time invariant, okay? Here, I first put, instead of t here, I put t minus t0. And if there's a shift to my system, then it would be like 2t minus t0, only shift. So first squeezed and then shifted by t0 seconds, okay? I hope this part is clear to you, arkadaşlar. And then we will continue with other properties.